In this video, I'm going to show you how to draw some 3D molecular geometries on a two-dimensional surface, such as a piece of paper. So we're going to start out with a tetrahedral example, and we could think of the tetrahedral example as space filling like this, but what I'm going to do is really focus on a ball and stick representation for a tetrahedral molecule. So when we look at tetrahedral molecules, there are two common ways to think of them and draw them. And one is to place three of the atoms on a surface and notice that they're rising up off the surface, and then there's one atom extending upward. So that sort of lends itself to thinking of a triangle and something coming up. So we'll look together at how to draw that. So what I would do first is draw two of those atoms, and in my model I'm thinking right now of the red and the green. And then in this model, the white is going behind the board or the plane of the paper, and the blue is coming up toward me. So what I'm going to do for the blue one is sketch a wedge. I'm going to fill that in. And for the white one, I'm going to use this dashed line to represent that it's coming or going away from me. So the wedge is coming forward. These two are in the plane of the paper, and then the dashed line is going behind the plane of the paper. So that's one way to draw the tetrahedron. Another way is to rotate the tetrahedron so that two atoms are coming toward you, in this case the red and the blue, and two atoms are going away, in this case the white and the green. So and by the way, I could rotate it this direction too, or this direction. So how we draw that is to use our dashes and wedges. I will have two of those atoms coming toward me, and two of the atoms going away. So one advantage of the first sketch here is that I can more readily translate this in my mind's eye to a three-dimensional geometry. One advantage of this one is that I can think of those atoms in pairs. So when I'm trying to work on things like dipole forces, that might be helpful. So that's our practice drawing tetrahedra. When we get to other geometries, for instance, this one's a trigonal bipyramid, where I've got an arrangement of 120 degrees for three atom groups around the central atom. And then I've got a 90-degree arrangement between these atoms on either end and those that are in that equatorial position. So we actually think of this as an equatorial position for the ones with the white pegs, because they're kind of like projecting along the equator of a sphere, if this were occupying a sphere. And then these ones that point up and down are kind of like the North Pole and the South Pole of the sphere. So we call those the axial positions, because they're along the axis of north and south. So how do we draw that? We're going to borrow a tip from when we were working on our tetrahedral model and think of using dashed lines and wedges, and go ahead and sketch that. So for those axial positions, that's pretty straightforward, right? We're having one bond go up and one bond go down. And then we're going to have the equatorial positions come in. One of these goes out to the side, like this one. And then one is coming out toward you, like so. And then using wedges or a dashed line, we have one atom going back behind the plane of the paper. So here's our in-plane bond, one coming toward you and one going back. So that's a trigonal bipyramid sketch. Now when we get to a larger molecule, or one that has more atom centers, like the octahedral, how do we draw that? So in this octahedral example, I'm going to rotate this. We can think of this as kind of like having axial positions, right? So these four reds could prescribe an equatorial position, and then these two white ones could be axial positions. And that's helpful for thinking about how we might sketch this one. By the way, there's 90-degree angles between all of these bonds that we see. No matter which way we rotate or which pair we're looking at, there's always a 90-degree angle. So for our octahedral structure, we can draw the axial positions, and then add our equatorial positions, again using filled wedges coming toward us and dashed wedges going away. So to any of these models, you can add atom labels, at the terminus of each of these. So it could be atom A, atom B, and so on. You could also sketch these with a central atom in the middle, so atom C, for instance, and go ahead and use those as you like. So there are some quick tips for drawing tetrahedra, trigonal bipyramid, and octahedron. Good luck.